Hi everyone, my name is Pritam Ray. I will be the TA for the course Deep Learning for Natural Language Processing. This is the tutorial for week 1. We will be having 12 tutorials each for 1 week, which will be taken by my fellow TA, and let's go ahead with the tutorial. So in this first week we will be learning about n-gram language model. So this is a Jupyter notebook that will guide you through the basics of n-gram language models using Python. So this is a notebook which Google Colab notebook, which we will also share through our course website. So first let's import the required libraries which we will require for this tutorial. Now what is an n-gram? An n-gram is a continuous sequence of n items, words, characters, etc. from a given text. For example, in the sentence I love machine learning, the 2 grams or the bigrams are I love machine and machine learning. Mathematically, the probability of a word Wn given its history H, history we can also say as a previously occurred words in the n-gram model, is given by probability of word Wn given H, the count of H comma Wn divided by the total count of over the whole corpus. Now this is a helper function that generates n grams, which takes in input text and the size of n grams, which returns a list of n grams as tuples. Now let us run the code. For our own use case, we have added a padding with hash characters to handle the start of the sequences. So as you can see, padded text equals to hash with the other characters in the text. Now let us see an example. So the text is hello world. Now we generate and display the bigrams or the 2 grams from the hello world. Now when we run this, the character level bigrams are hash h, since we add a hash padding in front of each of the characters, the starting of the character. So hash h, he, el and so on and so forth throughout the last l and d. Now let us build a bigram n-gram language model which takes in a corpus text. So the corpus is basically the text corpus for building the model, and n, which is the int or the size of the n grams, which returns a probability distribution for each context. Now for our toy n-gram model, we initialize the model as a dictionary of counters which will count the bigrams for each of the bigrams. So we generate the n grams from the corpus, and then from the helper function above, that from here. Now we build the model. So here what we are doing, we are basically counting which character precedes which character, and we are adding +1 to the occurrence. Then we convert these counts into probabilities, which is as simple as dividing the counts of the occurrences of bigrams divided by the total number of counts. Let us run this. Yeah, and now we have a model. Now moving on, we also know the concept of smoothing. Smoothing assigns a small non-zero probability to unseen n grams. Now mathematically the probability becomes the same, but we see that an alpha parameter has been added to the numerator, and the alpha into the corpus vocabulary is added in the denominator, which helps the model to to assign unseen n-grams to probability that will not be 0. So, let us learn this. Now, in this section we generate text using a n-gram model. To generate text, we sample the word using we sample from the model using probabilities of the next word given the current context. So, here this function generate text takes in our trained n-gram model, the size of the n-gram, the initial text to start the generation, and the length is the number of characters to generate, which returns a generated text. So, here the current text is basically the list of the start of the text star list, which is converted, and in this loop we are basically sampling the next character which would come in the next occurrence given this start text. Let us run the code. Now, let us see we have a how this our trained model runs, trained model generates text. So, we have a text, we have a sample text hello, this is a sample text for testing the n-gram model. Now, we build a bigram model using the helper function above, which takes in the text corpus to be trained and the size of the bigram, size of the n-gram model, which is 2 here since we are building a bigram model. Now, generating text we call the generate function, which takes in the model, the size of the model, the size of the model, the starting and the number of characters to generate. We run this. As we see, it generates 10 characters, but since it is just a dictionary, the meaning is not perfect, it is pretty gibberish here. But the thing is, it is generating characters given the word he. So, he is present and it is generating LO space INGRAMO 10 characters after the context is given. Now, after generation we need to evaluate the language model. So, a common way to evaluate a language model is perplexity. So, perplexity is basically the it can measure how a language model predicts a test data set. It is given by this equation. The lower perplexity indicates a better model. So, this is a helper function which calculates the perplexity of a model which takes in a model, the size of the n-gram, the test str, the text, the text we would evaluate the model on, and it returns a score which is pretty commonly a floating point integer. Now, let us create a more substantial training corpus for training a model. So, this is a training corpus, as you can see it has much it is pretty big for a character level language model. So, here we are cleaning the corpus, we are removing any alphanumeric and any space from the training corpus and converting it to converting everything to lowercase. So, let us see the training corpus. This is what the training corpus looks like. The \n is basically a new line character that has been appended to the training corpus. Now, this function here we will build models of different orders in the sense bigram, trigram and 4-gram models on the same corpus here that we have just cleaned, this corpus, which will build the here we will call the build n-gram model, which takes in this corpus training corpus and which of size n is here basically 2, 3 and 4 bigram, trigram and 4-gram models. So, let us build our this bigram, trigram and 4-gram models. Now, let us generate samples. Now, this function evaluate samples, it generates samples and calculates perplexity. So, here the function evaluates multiple n-gram models by generating text samples and calculating their perplexity scores. Now, this function takes in different n-gram models. For each model, it generates multiple text samples, as you can see number of samples, and calculates the perplexity for each sample, computes the average perplexity for all the samples, and stores and returns the all results for comparison. The parameters of the evaluate samples function is basically models, a dictionary, the number of samples which is int, the number of text samples to be generated by the model, and the sample length, the length of each generated sample text sample in characters, since we have created a character level bigram model. Now, let us run this piece of code and let us evaluate the samples on the models. So, as we can see, the evaluate function, the evaluation below. So, for the 2 gram model evaluation, sample 1, the text is this. You know, the perplexity is very high because this text still it is still outputting gibberish sentence. It does not contain any meaning, but the good thing is it is able to generate sentences at a character level. Now, let us see sample 2. So, the perplexity is even higher. Now, as we have set the number of samples here to be 10. So, for each of the models, it will generate 10 samples with their perplexity scores. Now, similarly for average perplexity for the 2 gram model is 7.27. So, now similarly for the 3 gram evaluation, the sample 1 is this with the perplexity. As we see that the perplexity of a 3 gram model is pretty less than the bigram model. It is due to the fact that the model has more context to predict the next character. So, the average perplexity for the 3 gram model is 2.68. Now, similarly for the 4 gram model evaluation, the text one, the text is the grass in that golder like 1000 pow. It somewhat makes sense now than what we had in the 2 gram example. The perplexity, as we can see, is pretty low. So, this is a 4 gram model. So, the model has previously seen 4 characters, then it is generating a character. So, this model has much more context the model has seen much more context. So that it can generate the next character better. So, let us see sample 2, the text that the model has generated, the early bird catches best withingle step. Till here it made sense. After that it went on to generate some gibberish text, but the perplexity is low. Similarly, if you see all the other samples, the text of the 4 gram model makes much more sense semantically than the bigram and the trigram models. So, as you can see, the average perplexity of the 4 gram model is 1.49 compared to the bigram model, which is 7.27. So, it is a 6 point difference, around 6 point difference. So, the overall statistics is basically this. So, the average for the 2 gram is 7.27, trigram is 2.68. From moving from bigram to trigram, we have around 5 point difference, because the model has much more context and it can generate the next character better, since it has more context. And as you can see, the 4 gram model is the lowest, since it has seen previously much more characters than the trigram and the obviously the bigram model. So, in this tutorial you learnt about how to build a n-gram language model using basic Python, and how to build a character level language model similar like the bigram, trigram and the 4-gram language model, calculate the perplexity, generate text from the models and much more. So, please play around with this notebook, generate more number of samples, increase the sample length, use different corpuses and see how it goes. Thank you.